Section 1.2, Domain and Range, Part 2. In this section, we write a piecewise function to model a situation, we graph piecewise functions, and we evaluate piecewise functions. A piecewise function is a function in which more than one formula is used to define the output over different pieces of the domain. And this type of function may be new to you. It's not sometimes the first time you encounter a piecewise function is in a pre-calculus class. Some examples of piecewise functions are postage. So there are different formulas for how much you pay based on the input of how much your package weighs. Income tax. There are different formulas used to determine how much tax you have to pay based on the input of your income. And some data plans. So depending on how much data you use will determine how much you have to pay for your data plan. Piecewise functions always have this form. There's the name of the function. And then there's brackets because there's going to be several lines or several formulas. So there'll be the first formula. And then it'll say if, and here we'll tell you a piece of the domain on which you're going to apply that formula. And there could be a second formula, if, and then there'll be a second piece of the domain. So the domain is split up into pieces. There could be 2 pieces, 3 pieces, or even more pieces. And we'll take a look at some examples. Example, a yoga studio is offering 5 free classes. After that, students will pay $5 per class. Write a function that models the cost as a function of the number of classes. So x is going to represent the number of classes that a student takes. And so we'll write a function, we'll just call it f, that models how much is going to be paid. Now, the first 5 classes are free. So if x, which is the number of classes the student takes, is less than or equal to 5, then the cost is 0. But if x is greater than 5, so as soon as you take class number 6, you're going to have to pay $5 per class. Now here, we're not just going to write 5x, because if we wrote 5x, that would mean that we would have to pay for all the classes $5. We're only going to pay $5 for the classes that are more than x, more than 5. So the first thing we have to do is we have to figure out how many classes we're going to pay for. So we're going to take away the 5 free classes, and then that is what we're going to multiply by $5 each. And so that's our second formula. So let's just kind of review that again. So for example, suppose you take 7 classes. The first 5 are going to be free. And so how much are you going to pay? You're going to pay for 2 classes, or in other words, $10. So notice that if you took this formula and put the number 7 in for x, that would be 5 times 7 minus 5. In other words, 5 times 2, the 2 classes that you need to pay for, and you'll be paying a total of $10 for your classes. Let's do another example. A tour group charges $10 per person for groups up to 10 people, $100 for groups from 10 to 20, and $200 for groups over 20. Write a piecewise function that describes charge as a function of the number of people. So x is going to represent the number of people on the tour. And notice that the domain was divided into 3 pieces. So let's go ahead and start writing this function. The first piece is for the number up to 10. So in other words, if x is less than 10, then you're only going to pay a certain charge, and the charge up to 10 is $10 per person. So we could write $10 per person as 10x. Let's take a look at the next section. The next section is for groups from 10 to 20. So that's if x is between 10 and 20. And if we look at the description, in that section, they will pay $100. So it's not going to depend on x, but it's just going to be a flat $100 fee. And then finally, the third section is groups over 20. So if x is greater than 20, and if x is greater than 20, we can take a look at what the charge is. The charge is $200. So this would be how we would write that piecewise function. Evaluating piecewise function and graphing them. So let's graph this piecewise function. Now notice it comes in three pieces, where x is less than or equal to 1, where x is between 1 and 2, and where x is greater than 2. So let me put a scale on this graph here. Okay, and I'm going to let every 2 squares represent 1 unit. So I'm just labeling the axes to give us some idea of our scale. Okay. Now, whenever I graph a piecewise function, the first thing I always look for is how the domain has been divided. So it's been divided into 3 regions. Region 1, where x is less than or equal to 1. Region 2, where x is between 1 and 2. And region 3, where x is greater than 2. And in each region, there's going to be a certain rule applied. So in the first region, the rule that we're applying is x squared. Now, x squared we know is the shape of a parabola, and it's going to apply in region 1. So it might help to plot some points in that domain region. So for example, in region 1, if x is 1, 1 squared is 1. If x is 0, 0 squared is 0. If x is negative 1, negative 1 squared is 1. If x is negative 2, negative 2 squared is 4. And so that gives us some points to plot. 1, 1, 0, 0, negative 1, negative 1, 1, and negative 2, 4. So we can see it's this piece of a parabola that looks like this. And as we have an equal sign in our inequality, I filled in a circle there. Now let's take a look at our second region. In our second region, it just says f of x is equal to 3. Now our second region is only between 1 and 2. So for example, at 2, the value is 3. At 1.5, the value is 3. At 1.1, the value is 3. It's constantly 3. So for example, it would be this horizontal line here. Because we have an inequality sign here that doesn't have an equal sign, I'm going to fill in an open circle here. And because we have an equality sign here, we're going to fill in a closed circle on the right. And finally, let's take a look at our last piece. For our last piece, we have f of x is equal to x if x is greater than 2. So let's get some values for that section of the domain. So if x is greater than 2, for example, if x is 3, if x is 4, if x is 5, then f of x is the same as x. So if input a 3, output is a 3. Input a 4, output's a 4. Input a 5, output's a 5. And so we can get a sense of what that looks like. It would be at 3, 3. So at 3, 3, we would have a point here. At 4, 4. At 5, 5. It's the line that has a slope of 1. Now, where would it be at x is equal to 2? Well, at x is equal to 2, we notice that it would be heading to 2, but it would be an open circle because there's no equality sign there. And so here is a picture of what that last section of the graph would look like. Let's do one more example. So again, we always want to attend to how the domain has been divided. And so let's get an axis system here. And I'm going to let every 2 squares represent 1 unit again. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So when we look at our domain, it's been divided to the region where x is less than -1. So here's region 1. Between 1, -1, and 4. So here's region 2. And where x is greater than 4. So here's region 3. And we're going to do the same thing that we did before. So in the first region, we have x is equal to 1 cubed. All right. So that's the region where x is less than -1. Well, it doesn't apply at -1, but it's nice to know where it would be as we get close to -1. So -1 cubed is -1. 0, oh, well, 0 is not in that area, so we would not put in 0. So let's put in something else that is in that area. -2. -2 cubed is -8. -3 cubed is -27. So we can see that it's just getting more and more negative as we plug in those values. So -1, 1, -1, 1. I'm going to graph with an open circle because this inequality does not have an equal sign. The next one would be -2, 8. So we can see that it's just decreasing very quickly. All right, let's move on to the second area of our graph. So in the second area of our graph, the area between -1 and 4, f of x is equal to -2. So when you plug in -1, you get a -2. Plug in 0, -2. 1, -2. No matter what you plug in that area of the domain, you're always getting a -2. So notice here that we also don't have an equal sign in the inequality. So I'm going to graph that with an open circle. -1, -2 would be here. I'm going to graph that with an open circle. And notice it's going to be that way all the way till 4, again, with an open circle. And finally, our last section. So in our last section, we have f of x is equal to the square root of x. So x, f of x. Now let's put in a 4. If we put in a 4, we have the square root of 4, in other words, 2. If we put in a 5, we would have the square root of 5, which is a little more than 2 point something. The next interesting number to put in would be a 9. If you put in a 9, you have the square root of 9, which is equal to 3. So what you can see is that this is a very slow growing function. All right, so at 4, I'm going to use an open circle, and I'm going to graph the point 4, 2. So at 4, 2, this is where it would start. Now notice that it's very slow growing. It's not going to hit a y component of 3 until x is 9. And we remember, what does a square root function look like? It's a very slowly increasing function like this. And so that's what that piecewise function would look like. So that's graphing piecewise functions, and now it's time for you to practice.